So this is a topic from A-level integration by substitution. Okay, so it's asking, by using the substitution, u is equals to cube root of x, or otherwise show that the integral of 2 over x plus cube root of x into dx is equals to 6 ln 2. Now, it's specifically mentioning that use the method of substitution and use that u as cube root of x. So it's always better to go with the, the referred method here, although it says otherwise. Okay, so step one to a substitution problem is always deal with the things that you need to substitute it in first. Okay, so the part that we need to sub it in, we need to substitute for x here. It's nicer if your x is the subject, otherwise rearrange it. Sometimes it's easier for us to spot how to substitute it. Sometimes you need to rearrange it to make it a bit nicer to substitute these things in here. So we can rewrite this as x is equals to u cubed. Okay, then you can substitute for x here and here. This next part that we need to do here is the dx. You need to substitute for dx. We are integrating this with respect to x, but when you start substituting u in here, you need to integrate with respect to u. So you need a du rather than dx. So this dx also must be substituted. So what we're going to do is differentiate this. So we have dx over du is equals to 3u squared. Therefore, dx is equals to 3u squared into du. So this is our substitution for x here. This is our substitution for dx. Okay. The next part of the problem is our limits. These limits are for x. So what we need to do is we need to convert these limits for u. Okay. Otherwise, what you have to do is you have to resubstitute the x back in if you want to use these original limits. Okay, which is a bit long and complicated. So it's always better to convert the limits as well as your variable that you're changing here. So all the limits should be in terms of u here. So if x is equals to 0 using that function over there, you're going to end up with 0 is equals to u cubed, which means u is equals to 0 as well. So that's your lower limit. Your upper limit is going to be x is equals to square root of 27. Now, root 27 can be rewritten as 27 to the power of a half. 27 is 3 cubed. So 3 cubed to the power of a half, we can rewrite that as 3 to the power of 3 over 2 here. Okay. So if I substitute that into this function over here, you're going to end up with, so x is 3 to the power of 3 over 2. That's equals to u cubed. So you can times by a third on the both sides of the power. You'll end up with u is equals to 3 to the power of a half. Okay, so 3 to the power of a half, we can rewrite that as root 3 here. And that is your upper limit. So now we've got the substitutions that we need. We've converted the limits. Let's integrate it. Okay. So the integral here then becomes, the limits are 0 to root 3, 2 over, so x would become u cubed plus cube root of x is going to be cube root of u cubed, that's just going to be u, and then dx will become 3u squared into du here. Okay, I don't need the bracket symbol here. And we can now simplify this. Okay, so what we can do is 3 times 2, that's a constant. Constant doesn't need to be as in the integral. You can take it out of the integral and leave it here. We don't need additional complications added to this. So that's root 3. You can simplify it now. So u squared over u cubed plus u. You can take a u out of all of that. So u over u squared plus 1 into du. Okay, that in itself looks a bit like an integration by another substitution sort of question, but if you can spot that the differential of this is the numerator. So what it normally looks like is the integral of, so the denominator is f of x, so the differential of the denominator is the numerator. If you can spot that, then the answer to that is ln of modulus of f of x plus c. Okay, if you can spot that, your integration will become much easier. You don't need to do an integration by substitution. So we can see that here, isn't it? So u squared plus 1, the integration of that is just 2u. All we are missing is a 2 here, so just need to replace that with a 2 in the front. So that becomes 2u over u squared plus 1 into du. You can't just add a 2 here and not adjust the constant. Okay, you can't randomly bring in a 2. So you do need to multiply by a half. So that becomes 3 square root of root 3 2u over u squared plus 1 du. Okay, now you can see that it looks exactly like that. The differential of the denominator is the numerator. Okay, so we can rewrite this as 3 ln u squared plus 1. Okay, we have to substitute the limits in now. So the limits here, so that's equals to 0 and root 3. So if you substitute the limits in here, 3 ln of u squared, root 3 squared is just 3, so that we can rewrite that as 3 plus 1 minus 3 ln. So if you substitute 0 here, that's just going to be 1. Ln 1 is going to be 0, so that's 0. So what we are left with is 3 ln 4. Now, if you remember the question here, it says 6 ln 2. From here, we can see that 4 is 2, can be rewritten as 2 squared. So that's 2 squared. And if you know your log rules, you can bring the 2 to the front here. So that's going to be 6 ln of 2. Okay, as requested. Thank you for watching.